you are supposed to have a picture. Do you shift your signal to the left or to the right? Okay, that's the most important thing. Right? So now you have a little better feeling about the shift. And for the reverse in the time function, and again, we start from the signal x of t. If we reverse the time or reflect the time, we rotate the signal about the y-axis. Okay? We flip the signal around the y-axis. So that's the reverse in time or reflected in time. And another two actually. Compression and expansion. Compression and expansion. Okay, x of alpha times t, where alpha is bigger than 1, that's compression. And look at the figure here. Okay? Again, we are given a signal x of t. Now if I multiply the t by 3, so actually compress the signal. Okay? Compress the signal. And then if we multiply the t by 1 over 2.5, that's about 0.4, right? Okay? Then we expand the signal. Expand the signal. So this kind of operation will be seen later on, and which is very commonly used. All right? Okay. Right. Okay, so let's look at So I need you to sign the iCloud. Open the lecture notes. Okay? In the iCloud, you will find the lecture notes. So please copy this code. Copy the code onto your MATLAB .m file. And you have to open your editor. Open the editor of MATLAB and copy those commands. Okay. Copy those commands into the MATLAB editor and then run the program. See what happens. I think you also need the okay? So again, please sign in the iClass so that you can access the lecture notes. And then you do that one more time for you. Sign in your iClass, okay? In the chapter before the announcement, there are other chapters. For the week 0, you will see lecture notes here, right? Okay, and then open the lecture notes. And then go to the page, thing, 500. I need you to copy the commands. Copy all the commands into your MATLAB editor and run the code. But in addition to the main program, you also need the subroutine, subfunction. And I highly recommend you to read this subroutine, the function. That's a quantization effect, quantization operation. And the quantization. Okay? So you have a feeling on the result. And the output will be the one that I showed you in the previous hour. Your output will be those four figures, okay? You are going to generate a continuous signal, solo, okay? Because the time interval is very small. And then you are going to sample the signal. And then quantize the sampled signal. And then show you the error between the quantized signal and the analog signal, original signal. Okay? Then please, as I said, next week you have to show me your laptop, okay? Make sure that you don't miss it. Because if you run it, you will see the output is much more better than the reading side. Actually, you also can play around it, see the effect of quantization. The Q is the quantization level, okay? Q is the quantization level. You can change the Q, see what happens, okay? Play around it. You use smaller Q means you increase the number of quantization level. Then your signal, your quantized signal will be much more accurate. And it's going to reduce the error. Yeah. Can you copy that? I think you can copy that, right? You have to open your editor. This is a .NET file. It's very tiny. You have to edit. You have to edit the contents a little bit. You have to do that manually. Make some corrections. Okay? Yeah. If you do it right, it should work. Okay? I mean, there are some, like I told you in the beginning, there are some mistakes. There are some errors or mistakes when you transform the context from here to your MATLAB editor. Okay, that happens. Yes, I know that. Okay? So you have to edit your command or your context, copy from the lecture notes manually in order to make it work. Okay, you cannot, copy the command into your MATLAB editor. You have to open the MATLAB editor in your MATLAB and then run the code. But before you run the code, you have to make some corrections, okay? You won't be able to run the code directly because there are some kind of mistakes. If you copy this into your MATLAB editor, you have to do some corrections manually. Okay? You will not be able to run the code directly. I want you to do this because you will go through some difficult time and you will learn something from there. Okay, I will not give you the code directly. I have the code, but I'm not going to give you the code directly. Okay? You have to fix the problem. Okay? Okay? Could you share with your classmates? All right? share your computer with your classmate for the moment. I will ask everyone to bring your own computer next time. So for the moment, please share your computer with your classmate, okay? Sorry about that. I need you to, next time I need everyone to bring his own or her own computer. Yeah, share with your classmate. Could you, hello, Diane, share with your classmate? Crowded. Okay, is that okay? Is that okay? Yeah. Teach each other, okay? Teach each other, right? I will run a code. Again, like I said, you won't be able to run the code directly if you copy the contents from the lecture notes. You have to make some corrections. Over here, there are two equal signs. Okay? I think you should know that, okay? You need both the main program and also this quantizer subroutine. It's on 499, on page 499. If you are done, you can play around with this by changing the quantization level. Okay, Q equals 2, you reduce the number. Say Q equals 1, Q equals 0.5, Q equals 0.2, see what happens. Share with your classmate, okay? Is that okay? Use English, okay? Are you okay? Both the main program, also the subroutine for the quantizer. Okay? Yeah? You have to make, you have to delete some of the unnecessary steps, yes. You have to correct that mistake, the typo, the mistake. Okay? Yeah, I know there are some problems. If you copy that directly to the page like that. Or you can use another editor first. Okay, and then rename the file. Maybe that's easier to make a correction of all the edit events. Another way to do this is to use another editor. Okay, some of you may like to use, say, a Notepad, something like that. I don't know. Okay, for me, I like to use Win Editor. Okay, and use those editors, or just Microsoft Editor or Notebook. Comes with the Microsoft. Comes with the Windows. Copy the commands to the notebook, I think, or Win Editor, whatever. Or Notepad, and edit your file over there, and then rename the file so that method can run the file, run the code. Okay, that's another way to do it. faster way, okay? A quicker way to do that is the following, okay? Let me show you that. Okay, let me do that again. Okay? Suppose you want to reduce the space. For example, so I'm copying the following four lines into a notepad. Let me do that again. So there are some space, right? You want to reduce the space. The quicker way is to use replace. Okay? Put the one space over here. Okay, it's over here. So put a space over here. There's a space over here. And nothing here. Replace everyone. See that? So there's always a method to do that, okay? Use your imagination. Use your own imagination to do that. Just 1 second. Okay, got it? Now, in the editor of method, you also can do that. You also can use the following trick. The trick that I show you. Okay? Got it? Will that help? Okay. Alright, so this is the first time, so let me give you another. Would that be possible to finish it in 10 minutes? Okay? You need another file to save the top timers, top 10. Okay? One main program, one subroutine for the top timer. You need 2 files. Otherwise, you are going to append, or you have to append this subroutine at the end of the main function. That's another way. But I don't recommend you to do that. Is everything okay? You have to fix all the problems yourself, right? I'm not going to do that for you, okay? You learn from your mistakes. You learn from your problem. Is everything okay? Yeah, I have to reduce the space. Okay? How about you? You okay? You can learn from the mistakes. That's the best way to learn something. Sorry, can I see? Oh, I keep trying to kill my. That's it. Put a semicolon before the put a semicolon. Let me see. You may need to put a semicolon after the event so that it does not produce the output. These are the output from sample. Yeah, you figure out that by yourself, right? I did that. Alright, okay? D gives you the output from the code. So this will produce the output. If you don't need this, you put semicolon, then this will be disabled. Then you will not display all the work that is wrong. Okay, again, I'm going to teach you all the steps, all the mistakes. I'm not going to help you to finish, correct the mistakes. Okay? Yeah, go ahead. Sorry. You need, okay, you need this main program. main program. It's on page 501 and 502. Okay? But in order to run this main program, you also need this subroutine, this function, quantizer. The quantizer is on the page 499. Okay? You need, like I told you, two files. One is for the main function. Another one is for the subroutine. Okay? The quantizer is a subroutine, sub-function. Sorry, I cannot teach you at this moment to correct all the mistakes. I need you to learn that by yourself. I have to ask you to learn from mistakes. Got it? Okay? Try it. Fine. Okay? Don't ask me whether it is correct. You have to have this result. Okay, you are supposed to see the output like this. Sorry, hold on. The figures. You are supposed to see these four figures. Okay? From the plot, there are some plots, right? In the main program, there are some plots. These are the plots, generate the figures. Okay? So you are supposed to see the figures, the output are the figures. Four figures, 221, 22, 2223, 2224, right? It's a 2 by 2 matrix, and there are four figures. Oh, another arrow comes from here, so you can put semicolon behind the command that will disable the output. You don't need to see the error at this moment. Okay, got it? Put a semicolon. Put a semicolon. The full figures are generated by the command subplot 221 subplot 222 subplot 223 and subplot 224. Okay, so your outcome are the four figures. If you have error signal, the numerical value for error, disable it by typing the semicolon and the name of the command. That will disable the output. not supposed to fix all the problems by yourself, okay? Learn from the mistakes, learn from the trouble, learn from the difficulties. Okay? Okay, what's that? Come on, have a look there. So these are the output you are supposed to have. Did you see the output? Anyone? Did you see the output? Could you show me your output? Okay, good. What about the remaining two? We have only two spots, two figures, right? Four, yeah, we have 4 figures. Hold on. This is the center of the signal. Okay, and this is after quantization. After quantization. And this is the error between the quantized signal and the analog signal. So you have to give me all the 4 figures. 1, 2, 3, and 4. To run the program, you need, like I told you, you need also the quantizer. That's on the page 499. You also need this quantizer, right? Okay? It's on page 499. have to try to fix the error by yourself. Okay, I cannot tell you this that is the rule. Okay? I'm sorry. We have to learn by error, by mistake, by any non-successful process. Still does not move on. Identify the arrow. Okay, where does the arrow come from? Got it? Come on, only 1 inch to go. The last step, okay? If you cannot finish this, this will become your homework assignment. So it's better to finish it in a few seconds. Are you done? Are you okay? Some mistakes, still some mistakes. If there are some error messages, identify the error message. Where does the error come from? Okay, 1, 2. Oops. We need another 2 meters. This is okay. Something wrong here. This is missing. You need 4 meters, like I showed you. So that means there is something wrong in your quantizer. Okay, we need this function. This is on page 499. You need this function. In order to finish figure 3 and figure 4, you need a function on page 499. Okay, and also 500. I think there are 2 more comments. Yeah, over here. And since this error message, this error e equals x minus y does not have a semicolon here, this will generate lots of numerical values. Please disable it. Okay, you don't need it. So put a semicolon. Put a semicolon here at the end of the command. That will disable this numerical value, the output from E. Okay? Then you won't be able to you will not see the error again. disable this by adding a semicolon at the end of the command. Otherwise, you will see the output from the error message E. I'm sorry, error signal. Error signal. E is the error signal. Now, give me 1 second here. Now, this quantizer, some routines given by the author of the textbook, okay, it's a little bit lengthy, Another one, put it this one. This is taken from Wikipedia. I think it's good. You can try this. In the Wikipedia, someone gave us this function for the quantization. Now this is a rounding off type quantization. You can try this by yourself. It's much more simple. But like I said, there are many different types of quantizer, either rounding off or truncation or something else. Okay, some other types. And this belongs to the rounding off quantization. And you can see that it's much more easier than the one given by the author of the textbook. Sorry. Okay, again, this is a little bit longer than we expected, right? Okay, but you can try that. Okay? Just give you a feeling of how to write a quantization function. Okay, some of you have finished one half of the code. Okay, they come up with 2 figures, but another 2 are missing. You have to finish. You have to finish the code. There are 4 figures. In order to have the complete output, you are supposed to have 4 figures, right? One is analog signal, one is sample signal, then quantized signal, and then the error between the quantized signal and analog signal. 4 figures.